Next, we want to look at creating a graph with StrategyWizard. Graphs are important because they let you identify both trends and robustness in your parameter results. We have two different types of graphs that we use for this purpose in StrategyWizard: the 2D graph, which produces scatter plots, and the 3D graph, which produces surface plots. These can quickly be used to determine the robustness of a strategy. Going to Strategy Finder again, I'll quickly show you how to set up a graph of each type. To set up a 2D graph, you click on the 2D Graph tab, and you have a couple of settings at the top. The first one is the parameter. This parameter determines what the x-axis of your scatter plot will be. Additionally, you have output. This determines what the y-axis of your scatter will be. Here we're looking at the fixed profit stop profit level for our x-axis, and the output being the backtest profit per trade for the y-axis. In the scatter plot, every combination of parameters from your Strategy Finder run is represented by a dot. This dot is one run that had a 0.5 profit level, and its profit per trade was just slightly larger than 0. This is another run with also having a 0.5 profit level that had a profit per trade of just over 0.1. Here you can see one with a profit level of 2 and ending up with a profit of negative 0.7, and continuing on until you have all 24 of our permutations here. You can also change the shape to suit your viewing tastes. You can choose stars, or my personal is I like the squares. There's square. And any of your parameters that you defined in your experiment are available for you to graph. So we can also look at the fixed loss stop level, and that's a totally different graph. Additionally, there's the display average checkbox, which is generating the connected lines with the star. By unchecking that, that goes away, so you can see the pure scatter. At the bottom, there's load and save, which allows you to load and save results from a previous Strategy Finder run, or save off your current results for future analysis. This way, after you've done a run and you want to return to those results, you just have to click the load and bring in your old results. Looking at the 3D graphs, these create surfaces, which are very useful for identifying combinations of two parameters and their smoothness. Here you choose two parameters to be your x and y axis, and then an output metric, such as profit per trade, to be your z axis. And any of the parameters defined in your experiment are once again available. By moving the sliders at the bottom and on the side, you can move through and examine the curve more closely. This will let you identify details that may not be apparent if there was one fixed view. So now that we've seen how to produce the graphs in StrategyWizard, we want to examine exactly what it is we're looking for from those graphs. We'll start by examining scatter plots. Scatter plots are used to compare performance results versus a single parameter's values. So you would compare something like profit per trade to the level of your fixed loss stop, as was seen in the previous example. When looking at these scatter plots, we want to look for the values of the parameter which have the highest overall performance, provided the scatter has a degree of smoothness. The smoothness and trends within the scatter show signs of robustness, which is necessary for the strategy to hold up going forward. Scatter plots are extraordinarily useful for tuning the base systems of your strategies. For example, trading a moving average crossover system and wanting to know the number of periods. Scatter plot will tell you exactly what all the possible outcomes for the moving averages are, and if short moving averages are performing better than long moving averages, or if there's a sweet spot around 34 periods, say, it will give you a wealth of information to determine whether or not what you're finding is just a statistical anomaly, or if it's an actual phenomena that is occurring within the markets. As you can see, the scatter plot holds a wealth of information. A quick example of examining the robustness is to look at the two scatter plots in the right on this slide. You can see that the top scatter shows a definitive trend of, as the parameter value increasing, performance decreasing. This tells you that large values of the parameter are likely to perform poorly, while small values of the parameter will perform well. Looking at the bottom chart, there's not much of a trend displayed in the chart. Most of the bands overlap, and there's very little pattern to it, with the exception of every value of the parameter has a wide range. This tells you that your settings for this parameter are not determinative of performance. Adjusting this parameter gives you very little ability to achieve better performance. The next type of graph we will look at is multivariate graphs, or surface graphs. These are used to analyze the relationship between two separate parameters and the associated performance. When looking at a surface graph, you're looking for peaks, provided that they are smooth around that peak. Again, the smoothness is a very good indicator of the robustness of the strategy. Surface plots that have a lot of large peaks and valleys are generally considered unstable or overfit, while plots that are relatively smooth show robust tuning. To the right again, you can see an example. I've included two examples of surface plots, with the top again being a very smooth surface with having some small peaks, but overall relatively smooth, especially comparing to the bottom, which has huge large peaks. A way you can think of this is that if you chose the parameter at the very top of the large peak, but the true best value was one step off of that, how far would your performance suffer? In the bottom graph, you can see that it would drop off dramatically as it fell off the edge of the cliff. While in the top graph, picking the peak, taking a step lower, is generally a value that is similar to the previous one. Past research shows that the use of surfaces is extraordinarily good for examining combinations of fixed profit and loss stops, which give you a great insight to the value of a strategy's signals. The third type of analysis, Boolean analysis, is analysis performed on parameters which take on values such as yes, no, true, false, enabled or disabled. To compare Boolean values, you want to look at both the range and the average of the scatter. Whenever you look, considering the top right corner image, you can see that the value of 0 has a lower range than the value 1. The average is also lower, but it is fairly clear that the value to the right produces a markedly better performance. The highest are higher, the average is higher, and the lows are higher. So based on any setting you pick in here, most likely it's better than the setting found if the parameter was set to 0. While if looking at the bottom Boolean scatter, you can see that the one on the left, the group on the left and the group on the right are not quantitative or qualitatively very different. The average is slightly lower on the right, but the range is to where these are fairly likely to be a statistical anomaly. There's no value to turning the filter on or turning the filter off, or enabling or disabling, or true or false. It's the same either way in terms of results. We most often use this Boolean analysis to determine whether or not filters or confirmers help the performance of our trading strategies.